So yeah, we're starting over, and again, welcome to DCG's regular platform development update. I'm Marina, and today I'm hosting this event instead of Balázs, so we had some technical difficulties, but now everything seems to be fine. So we're having 5 teams speaking for around 1 hour. So again, make yourself comfortable, like and share the stream, and feel free to share your thoughts in the chat. Let's get started. So I'm passing this on to Lukasz.
Hi, I'm Lukasz. I'm a developer of TenderDash, which is our consensus engine. So our biggest goal right now is to finalize work on same block execution. And our progress is as follows. So basically all the features are merged. And right now we are on the integration stage with Drive. Drive team requests some changes and improvements from us, and we deliver that, and like adding some missing fields that they need and stuff like that. But these are minor changes. This also needs some stabilization work that we need to do. Once everything works, we need to test it. But the core feature is done and merged, and also released as a pre-release 0.10.0 dev 4. We also improved the way we calculate proof signatures. We had state ID in our system that had a separate signature. Right now, it is part of the standard block signature. So it decreased number of required signatures. So this should boost the performance of the network. And we are still investigating some deadlocks and issues like that. So hopefully that will be fixed very soon. And what's still left? So we need to, as I mentioned, we need to test the solution and stabilize it in terms of same block execution, eliminate any issues that can happen there before we call this feature closed. We have BLS library that is used to generate signatures, that is using old format of keys, and this task is to update that library, and we need to do it in a consistent way with core and with the whole platform. So this needs some coordination. We need to work on withdrawal transactions. We have some minor changes discussed that need to be implemented in order to finalize that, and we need to help the Drive team to integrate with TenderDash so that everything will work smoothly together. So that's more or less it on my side.
Cool, thanks. Yeah, cool. Thanks, Lukasz. Did we stop? Marina, did you stop presenting?
It was me. I was presenting.
Oh, you were presenting. Okay, I can present. Give me a second. I'll present from the rest from now on. Okay, so for GroveDB, we're going to do things a little bit different than usual because basically we were pretty much close to feature complete last time around, and we've been basically working the GroveDB, me, Wisdom, and Evgeny have been working in other teams to help progress for other teams, as the GroveDB tasks were less essential. So what we've been doing for this sprint review, for this development update, different from previous development updates, is that we're kind of showing more what's left to do. We saw that in TenderDash right before, and it's going to be pretty much the same thing in GroveDB. So what's left to do in GroveDB before the testing phase? The testing phase is once we have pretty much the system ready, but there could be bugs or there could be issues that become more apparent when we test. Obviously, like, we don't expect them, but things happen, right? So what's left? We wrote the sum trees, as was said 2 weeks ago, but we did have a pretty bad time trying to merge it with the fee branch of GroveDB. And we decided to spend some more time on this. Well, we needed more time on this, but it was not as essential as some other tasks that we needed to get done for fees. So we still have that to do. We also have another task called average case processing costs, where we kind of can give a estimate of the processing costs of various operations. It's not very complicated since we already have the worst case costs. The average case costs is derived from the worst case cost code. So it's not a very big task. We have some code polishing that we kind of wanted to do before the testing phase, just to make, well, it looked better. And a light proof feature. The light client proof feature is so light clients can verify proofs by using GroveDB. That's also minor. Well, it's between minor and major, but it's not a very big task. The majority of our work, I would say, is in protocol and in the Rust port for feature release. And so we're going to get to that soon. And with that, I will go on to give it to you, Igor, for SDK.
Thanks. I'm around. I would need slide switch.
Yes. Slide switch. And where is the slide switch? There we go.
Yeah, okay, thanks. All right. Good to be back. Glad to see everybody. I came back from vacation last week, and we continued working on chain synchronization process. So while I was absent, Adam, who is our QA, finished majority of manual QA tasks. And currently we are focusing on stabilizing platform-related features and workflows with the refined layer 1 synchronization process. So in practice, it means we're simply running platform test suite against testnet and spotting bugs, fixing them, etc., etc. So this is mostly the very last thing, the last big loss. And so far, the only problem we could have is the R reworks. Basically, if during the runtime of the test rework happens, the whole thing fails because we don't have rework handling in the wallet library yet. So we shall see how it goes. And if it's not a big issue for the wallet, we should push this forward and merge. If not, we shall cover the reorgs topic in the same pull request. Next slide, please. Yeah, I will also be reporting about Dash Pay web extension. Thanks, Ivan, for the last demonstration of the transaction sending logic on one of the previous reviews. So currently, Vasily, the guy who works on the extension from incubator side, works on migration of the manifest. This is a specific web extension thing. And we are migrating manifest v2 to v3 because this is a requirement of the Google Chrome store. They do not accept manifest V2 anymore, and so we have to upgrade. Yeah, this is it from this side, and yeah, let's switch to what's next. Yep, as I already mentioned, we will be working on reorgs handling and consensus rules fine-tuning, and also we should start researching and planning the work for secure keychain storage. Yep, this is it. Thanks.
Ivan, I think you're next.
Yeah, thank you. My name is Ivan Shumkov, and I would love to share with you the protocol team progress for the last 2 weeks. So mainly we worked on the same block execution, withdrawals, and the adoption, the integration, basically. And so we accomplished the fees last week in Errors Drive, and our recent work was related to integration, the fee calculation, new fee calculation logic with the JS Drive and ZPP. So during this work, we're fixing some bugs, and this work nearly done. Yeah. Javid, maybe you would like to talk about withdrawals?
Yeah,
since you
sure.
worked on this.
Thank you.
Thank you.
Hello, everyone. I'm terribly sorry for my ill voice. I'll be trying to tell you the progress about withdrawals. So this sprint we had a few stories for withdrawals. They were interdependent on each other, and few of them were in different places, like Rust platform and JavaScript platform. So the progress is that we have code ready we introduced a data contract for withdrawal documents. We implemented the pooling process only for type 0 only, which is like direct pooling. We have a code for updating a status of the withdrawal based on transaction, based on whether transaction is in core or not, chain locked or not. And we have a revision logic for identity credit withdrawal state transition. The code is ready, and we're having a first round of review, so we avoid redoing this over and over and save some development time. After this round, code will be fixed, and we will be moving to code polishing and covering it with tests. So that's it on withdrawals. We should go next. Kostya, I believe.
Yeah. So hi everyone. My name is Kostya. As I said before, we proceed with same block execution integration, and we started to add multiple transactions into JS Drive, but at this point we decided that we need some more investigation about it, so we postponed these tasks and decided to do other things in the while. So we added some additional fields to metadata, signature, block time, and around in query handlers, just additional info. It would be useful. It's in review, so we just need to merge the pull request. Next slide, please.
Sure. One thing though, very quickly, Kostya, when we say use multiple transactions for block processing, they're database transactions, guys. So
Yeah.
you get a little bit. Some people might not know that.
Yeah. In database, exactly. Reconnect logic in DAPI. There are some cases in which DAPI exits with error instead of reconnecting to TenderDash. Actually, I've almost fixed it today. It's just bug fix. So contact request documents allow invalid to user IDs. Yeah, it's a fix for Dash Pay contracts. The user could use to user ID which equals owner ID, which is not correct. Yeah, and another bug was that to user ID could not exist. So we added some additional checks for that. And the last two tasks are about switching to new validator quorums. We've added some additional checks before switching to the new one, Yeah, and so I guess it's pretty obvious from the titles. That's it.
Thanks,
Thank you,
Kostya.
Kostya. I would like to add that regarding to we're talking about the validator set quorum rotation. So we basically at this moment every 15 blocks we switch the quorum who is signing and validating the blocks, and these two tasks they're supposed to improve increase the liveness of make the more robust the system. So we won't switch to the quorums which are not could be expired, so or which are not really alive. Yeah, thank you.
Thanks, Ivan, for that. Sure. As I said earlier, less work was done in GroveDB because there was just less work done there needed to be done. So I worked on Identity v2. Identity v2 is necessary because the first way that we used to deal with identities was horribly inefficient, mostly because it was a proof of concept, and basically every single time you wanted to change your balance, every time you paid for something, you had to take the entire identity object, deserialize all of it, including the keys, and then change the balance, and then reserialize it and push it. In Identity v2, we actually use GroveDB to create an identity structure directly inside the database. So you can query only parts of your identity, only parts of identity of other people's identity. For example, when you're interacting with them through Dash Pay and you only want to get specific keys so you can pay them, or actually not pay them, create a contact request to that identity, but you don't need all of the identity information. You can just get partial identity information, and it's much more efficient, and it was really needed. The second thing is efficient data serialization. This is something where we have been working a lot on efficiency in GroveDB, and we needed to make documents and identities and contracts more efficient, and we can see already like a pretty good reduction in size as compared to the previous system that was using CBOR. The new system uses bin code or variation of bin code, which is much more compact. Okay, with that, I will pass it on to Anton. Oh, no, actually not Anton yet. We have a what's left for protocol. Ivan, you want to take this one? Well, I guess I can say the fee refunds in the meantime. Yeah, sure. I'll talk about fee refunds first. So one interesting part of the system is that when you take data out of the system, you get a fee refund. And that's been already coded up in GroveDB, where every single node in the system has an identity associated to it. So, well, unless you don't need a refund in the case of some contracts that are immutable, for example, right? If you write immutable data to the state, you can never get it out. I mean, it's there forever. And because it's there forever, you can never get a refund if you remove the data because it can't get removed. In the case that data can get removed, though, you get a refund every single time you remove data from the system. And the point of refunds is really to allow for, systems where data circulates really quickly. For example, games, right? So you put game data inside the system, and then you remove it, and then you add it, and then you remove it, and your fees are very, very low because you keep almost no data in the state. And yeah, so for fee refunds, even though it's accomplished in GroveDB, there's quite some work to do in protocol to support it. Basically, there's a list of all the identities and of all the fee refunds, but we can't apply that every block, because applying that every block would basically mean that we'd have to pull from every epoch, and there are 1,000 epochs. Well, at least 1,000 epochs. So basically, we have to batch the fee refunds every so many blocks to reduce the overall effect on performance. Yes, accomplish and test withdrawals. Why don't you take this one, Ivan?
Yeah, sure. So when we're done with the work with what Javid already explained, we need to have a little break from withdrawals because they're accomplishing and writing tests for withdrawals are blocked by the Rust DPP integration. So and basically this, when I say accomplish, I mean when we have Rust DPP integrated, we can write end-to-end tests and make sure that the whole code, the whole process coded properly, and like everything, there is no bugs. So it's more like finalizing thing. Also for withdrawals, we will add a DAPI endpoint to provide information regarding the current withdrawal limits, so clients will be able to plan withdrawals, their withdrawals. Then you can see the list of minor changes, the logging for same block execution. So when we accomplish the implementation, we want to log everything properly in detailed way, so we can analyze logs and see what's actually happening in Drive in the block execution process. Also, we need to change the way how the interface between DPP and Drive, which called state repository, works. So we could this change is required by switching to same block execution, actually. So, and we should be able to get data not just from the committed block context, but also from the block candidate. So when we execute state transition, and for example, we validating state transition against the block time, the state repository should give us the block candidate block time, not the previous committed block. So this needs to be changed as well as part of the same block execution work. Yes.
Yeah, I'll take the next two if you don't mind.
Yeah, sure.
Cool. So the next one is deal with situation where fees are higher than balance. It's actually just processing fees. So the vast majority of fees are generally storage fees, and then you can have some processing fees. It could be that the processing fees are high, but generally they're pretty low compared to the storage fees. And when you're executing the transaction, the state transition, it is possible that we get to a situation where the identity does not have enough balance to pay for the processing fees because they were badly estimated. In this case, basically the processing of the state transition already has happened. So there are two possible solutions. Either we spend more effort to revert the state transition, or we just, it's already happened. So, we allow it to occur and basically lock the identity from making any further state transitions. And when they do make a state transition, they have to pay that balance. Now, this is a situation where basically the identity can owe some money to the system, but when they owe some money to the system, let's understand that we're talking about microcents. But we can't give it to them for free because if we gave it to them for free, there could be an attack. So, they owe a little bit, like less than a penny to the system, and then there is no potential attack here because when they create their identity, the creation of the identity is pretty costly. So there's no way to actually game the system. And this is actually kind of a pretty good approach to solving the problem. Verify fee processing costs. Yes. So one other task that we have is that we have certain numbers for the processing costs, like a hash costs this much of a fraction of a cent. What do we have? Loading bytes from memory costs this much per bytes loaded, and stuff like that. Now, we derive those numbers from other projects, but and also some calculations that we did ourselves, but we really would like to verify that we are doing the right thing in comparison. So once the system is running, we should once we get the whole fee system running, we need to make a lot of these transactions, and then some that have like very high hashing costs, and some have very different loading from memory costs. And then based off of the various transactions that we have and the amount of CPU that it costs, we can have a better approximation of the actual fee that we should use, and adjust our fees a little bit in case we were way off. We shouldn't be, but it is better to verify this stuff. Yes, Ivan, you want to take over again?
Yeah, Sam, thank you. The next task is the asset lock and unlock transactions integration. And also this work can be done then we accomplish with Rust DPP part, and the main idea that the new transactions which were implemented in core and will be delivered as part of core 19 for identity funding, credits funding, and credits withdrawal functionality. So they should be incorporated in DPP. The new format, new special transactions. The next one, you already heard about it, probably we're talking a lot and it was like pain. The whole this task, this BLS library, Rust binding, and problem was with the compilation to the WASM. So we can use it not just in Rust, but also inside DPP and in browsers or Node.js. So we weren't able to make it comparable to WASM, and we figured out workaround for the which is pretty good one actually for the Rust DPP. So now we can finalize this work, and it's actually written, it's coded up, and it just needs some documentation to be updated, and just like basically go through it and make sure that it's complete, and review and merge PR. So it's not like the whole thing. Yes, and the masternode reward distribution. I think you heard a lot about this from Sam, especially discussing high performance masternodes. So for now, we don't have any decision made on what the percentage will be allocated for the platform nodes. Nodes who like the provide the platform service. But we still can make this functionality, right? And then we just need to change the number, the percentage, how much we would like to allocate for the platform service. So that work needs to be done. And that's basically it. The least what left for the first beta release.
Yeah, and just to be clear, the masternode reward distribution is pretty much the same in any solution that we choose, that the network chooses, basically. So the work, we're not, let's say that 90% of the work is not being currently blocked by that decision. That's correct, right, Ivan?
Yeah, absolutely. So basically, we just need to change the percentage. The number. It depends on which solution we go. So we can do this work in advance without waiting for the decision on distribution.
Okay, cool.
Thanks.
So Rust port update. Anton?
Yep. Hey guys, Anton's here. So today I'm going to give you today's update is going to be a little bit different from previous ones. And that's because we've decided to give you a more granular update on what's going on and what needs to be done to be sort of finished before we can release a first release candidate for the mainnet in terms of Rust update. So first of all, let's start with what was done in the previous sprint and stuff that we've completed. We had a lot of technical details that were needed to be figured out. For example, how to use regular expressions in the same way we use them in DPP now to prevent DDoS attacks and things like that. We also needed to figure out how to use BLS across different platforms consistently, which is Ivan just talked about on the previous slide. And we finished those stories and investigations, and with those we are done right now. Now, this was a part of a bigger story about what needs to be done to make Rust DPP work with the rest of the platform. Now we have two main areas we need to work on, and that's the first one is to ensure that the WASM DPP we've created is 100% fully compatible method to method, argument to argument with the existing JavaScript DPP. And the second one is to integrate the new Rust DPP into the rest of the platform, including GroveDB, SDK, all those things. And as I mentioned in our previous development updates, we were working on figuring out glue, how to properly pass values from Rust code compiled to WASM into JavaScript environments. And we've figured that out as well. So the glue code is finished at this point. It's not always finished, but it's figured out, and we don't need to work on this anymore as an investigation or as a big chunk of work. And while we were working on figuring out the glue, we've also ported 70 tests from the current JavaScript DPP, and we used WASM DPP in those tests. There is a total 1,174 tests to ensure compatibility between JavaScript DPP and Rust DPP. And as a part of making this glue work, we've ported 70 of them. As you can see on this slide, in every next update I will give to you, we will report on how many tests are passing to ensure the compatibility between new WASM DPP and the old JavaScript DPP. Now, it might seem as a high number, like almost 1,200 tests, but it's more since we've figured out all the technical difficulties that were preventing us from getting up to speed with this. Now it's just a lot of tedious work. Those tests are very quickly to do, and although like more of 1,000 tests sounds scary, it's not that large. It's not that large amount of work. And this is also a positive, because since we have that many tests, we can be pretty sure that the port is fully compatible with the old version, and we can safely reuse it across all the different platform components, including bindings for Android and iOS wallets and all that stuff, where we hopefully will use Rust DPP at some point as well. And that is about it. After we finished with those tests that ensure compatibility between old and new version, we will need our full test suite to pass with this new WASM DPP. And that is going to take some time. As you can see right now, it's not in progress. It's marked as planned here. And after this part is done, we can say that Rust DPP port is fully functional at this point, meaning that it was completely finished, ensured the compatibility with older versions, and fully integrated into platform and ready to go, basically. So yeah, that's the update from me. Thank you very much for your time. You're muted, Sam, if you're saying something.
I realized I was muted. Yes. Well, thanks very much, Anton. That was great. So here we
got
go.
A question.
Yeah. You want to read them to Marina, or read them to us?
So the only question about high performance master nodes, when are we going to drop the proposal?
Yeah, so there was enough people that wanted it next month compared to this month. So we'll come out, at the very first day of the cycle of next month.
Mm-hmm. Yeah.
The FAQ is pretty much done from our side as well. It's just being reviewed by people at the moment, and we should have that posted on our website soon as well.
Yeah, I think it's gonna be a great part of the website with all the questions we need to be answered.
Oh yes, fun things. I had
Yeah.
so much fun.
All right, I think we're done.
Wait, I'm sure there are more questions. Nobody has any more questions, guys?
We just need to be very careful with attacks. You agree with this?
We need to be very careful with attacks. I don't know what that was, but yeah, I guess no questions. Yeah. Well, when release? when released, guys. Trust us.
Yeah.
As what we've been trying to do today is try to show you guys what is left, and it's something that like is very important. Like we do have a lot of work left, and we can show it, but it's so little compared to what we've already achieved. So now it's buckled. I mean, it's been buckled down time for a very long time now, actually. But yeah, we just really need to finish the last few things, make a version that, you know, pretty much resembles the final version, and push it out. And hopefully at that point, incubator devs are going to be able to 100% work on it. And if they find any crashes or if there's any issue, then we'll know about it right away. And well, it will be in a much better state than it has ever been.
Fingers crossed. Fingers
Yeah.
crossed. Everyone's waiting for it. Cannot wait for it. So
Hopefully
we'll
a
be
good
hoping.
Christmas present.
Yeah. So yeah, I think we're done.
Yeah. Thanks very much, guys. Take care.
Thank you. Thank you guys for watching. Take care. Bye-bye. See you
Thank
in the
you.
next 2 weeks.